All right. Okay. Hey, hello out there. Hi, everybody. Welcome to Aaron's Solace Office Hours. And yeah, it's episode 50. I can't believe I have done 50 of these things. It started off during the pandemic. I was on Twitch for about 10 episodes before moving over to YouTube and LinkedIn. Thank you for joining. Today's episode is going to be, I think, pretty fun. It's not going to be a product demo. Like often we have our product line managers come on and show something about Event Portal or micro integrations. Last time was Ed Fonacutter, our Chief AI Officer, who did the Solace, SAM, Solace Agentic Mesh, AI Mesh, I guess. Yeah. If you haven't seen that one, be sure to check that out. That was a really great episode. Today is going to be a bit more fun, and I have a lot of people to help me out present today. So let's add them into the stream. Let's see here. We got Sanjeev, TK, Himanshu. Hey guys, Emily. Hello, Rainer. Hi everybody.
Hello.
Welcome to the stream. Thank you for joining and being here with me. This is by far the most number of people I've ever had on my Solace office hours. So yeah, rather than how about we just quickly go around the room, say who you are and where you're joining from. How about that?
Yep.
I can go first.
Someone go first.
I can start.
I can go first.
That's fine. It's fine. So Alessandro Cagnetti from Italy joining. So I'm SE for Europe South.
Okay. My name is Sanjeev, and I'm part of professional services in US here at Solace, and I work closely with customers to design and implement event-driven solutions that deliver real-time value.
Hi, I'm Himanshu. I'm a solutions architect based out of New York.
Hey, I'm Emily. I am an SE turned customer success, recently turned account director. I'm joining out of New York.
Hi, I'm Rainer. From Germany. I'm an SE for, Europe Central.
And my name is Thomas. I run the pre-sales engineering team for Solace for the Americas. And yeah, happy to be here and excited to talk to everyone about our hackathon projects.
I am excited for you all to be here. Thank you very much for doing this. I am in London today. I'm at the London office, and we actually have a full house. So I'm in a meeting room that I'm happy to be very quiet here in. Yeah, if you're out there, we are live on LinkedIn and on YouTube streaming. Put yourself in the chat. Say hello. Tell us where you're joining from. Oh, we already have a few people signing in. Hey, good morning. Good evening, Running Roach. How's it going? Thanks. Congrats on the 50th episode. Thank you very much. Timimi, good morning from Vancouver. Early morning for you. Hello. DT, good to see you. Hello. Thanks for joining. Hey, Mark. Mark joining from Florida, of course. Pascal from Germany. Another German. Excellent. Well done. Hello. Thank you. And yeah, here we go. Okay. So without further ado, we're going to do this in order. I got a slide here. I'm just going to whip up. So this is the order we're going to do. TK, you're going to go first, right? So until then, I'm going to put everybody else kind of backstage, and I'll bring you up for your particular thing. So let's go ahead and do that. Hello, Carol. Hello, how's it going? Welcome to the stream. Thank you for being here. And Vishal from Ottawa. Excellent, Ottawa. I will be back in Ottawa in a couple weeks. So yeah, awesome. Thank you for joining. Okay. TK, this is we're going to share your screen, I think, eh? So
yeah, we are. Yeah, just let me set it up beforehand.
Yeah, so, please. So it's over to you.
Yeah, the entire Solace field, so essentially the customer-facing folks gathered in London, and we presented on a hackathon project, and so the output that you see that all the teams are going to be presenting is on their various hackathon projects. So, Aaron, I'm assuming you've used large language models such as ChatGPT and Claude AI, right? I'm assuming that's part of your daily process.
I have a little bit, yeah.
A little bit, yeah. I'm sure a lot of people in the audience heard of it as well. So, for my hackathon project, I wanted to figure out how to integrate large language models with an event-driven architecture and show the fancy things that you could do here. And so what the team thought of, and shout out to my team as well, was Deepak based out of Toronto and Manish based out of India, who helped me build this project. But what we thought we'd do is show how the power of large language models could be integrated with an event-driven architecture to implement, in this case, dynamic price updates for a retail environment. At the end, I'll also show how the large language model can also manifest itself in changing the physical world as well. And so with that being said, I will now share my screen and key up the demo. And hopefully my share screen
Sounds
works.
good. Yes, of course. Yeah, and to everybody listening, yeah, these are team efforts. Thanks, TK, for calling out your team there. And yeah, we're happy to take some questions at the end of the presentation. TK might actually have to run and catch a flight, so if you do have questions, make sure to ask it before he runs off. Looking for your, oh, there we go. I can see it. Excellent.
Okay. Yeah. So this, one of the things with demos or when you present to customers in general is that it's always good to have something, eye candy to begin with. So this is just a little side project I've worked on in the past. And what it involves is, this is our Solace's mascot, Sol. It's an otter. I've taken a 3D model and applied holographic shaders to it in 3D JavaScript, and that's what you see here. And so you could rotate it around, you could move it up and down, and it's just a fun little project to just get into dabble in the world of 3D programming. Now that's not the demo. I'm gonna switch out to the actual demo. That's just the eye candy. Okay. So this on the left-hand side of my screen, you will see Claude AI, which is a desktop large language model interface built by Anthropic. And so what I'm going to do is I'm going to show how a prompt can be translated into an event and update this e-commerce storefront that you see here on the right-hand side. Okay. So I'm going to put in a prompt, and I'm going to say, I want to say, I'm a maintainer of this e-commerce website, and rather than updating a database or talking to my webmaster to update the price or add a new item, I'm going to use a prompt to do that. So I'm going to say, update the price of the laptop. And Aaron, what should I set the price of laptop to?
I don't know, $600. Pretty big
600,
sale.
Okay, fire sale. And I'm going to for store, and I'm going to use the store ID ecom. Every store has ID. In this case, it's ecom, signifying e-commerce. And I'm just gonna put that in the prompt, and let's see what happens.
Ooh.
Oh, sorry. Typo there.
Oh.
Update. See, you could see the schema validation in action as well.
The laptop 600.
Yeah, to 600 for store ID ecom. Okay.
Do you need the $sign, or is it smart enough?
No, I can, but I left it out for simplicity. Let's see over here. It is updating
animating.
The price.
Nice.
Yeah, it's animating as well. So shout out again to Debug for working on this web front end. And you can see over here what this has actually done is you can see the payload of the action over here. So price, product, store ID. And you can also see how the large language model was able to take this prompt and construct a rich Solace topic out of it. And so this Solace Store e-commerce website is subscribing to the various price update topics for the respective products. Okay, so there's each of these tiles essentially instantiates a subscription on these topics. Okay, now what if I wanted to add a new price? Say like the Solace Store has started manufacturing a candy called the Event Mesh Candy, and I'm going to create a prompt to go ahead and do that. Okay, so I'm going to copy and paste the prompt because it is a little bit more complicated to do it live. So essentially, what you see here, I'm going to say, please add the product Solid Candy with a price of $2 to store ID ecom under the category stacks. snacks, sorry, with an image URL as follows. So I'm going to go ahead and do that. You can see over here, there's no solid candy in this e-commerce storefront.
Right. Do you have a snacks category yet, or does that?
Oh, no, I
add it
don't. So
automatically?
it's going to go ahead and create it as well. Okay, so you can see over here, the snacks candy has been added. Again, what's happened is that the large language model was able to essentially parse out the prompt, get the payload from the prompt, as well as construct a topic that the e-commerce storefront is subscribed to it. So that's essentially how the large language model integrates. Now, I did mention in my introduction that I'm going to show you how a prompt could manifest itself in the physical world as well, right?
In the real world, yeah.
I'm going to switch over my camera over to my iPhone, and hopefully this works. Mirror my camera as well.
Oh,
okay.
Yep.
Okay, so you can see over here, I have an Arduino microcomputer that is connected directly to my laptop through a USB-C cable. And you can see over here that, you see that? Oops, let me turn my camera around actually. Okay, is that clear?
Maybe let's see if I can make it bigger. Yeah, oh, perfect, thanks to me. I was gonna do that too. I can, I can read a little bit. Oh. Chips.
Okay.
$5.
Chips,
I think it says.
Okay. So chips $5, right? So now I'm going to type in a prompt to update the price of chips.
All right.
Price of chips, and give me a price, Aaron.
$5 is way too much. So how about $2? $2.50.
$2.50. Okay. $2.50 for
half price.
Store ID.
You're doing this one-handed, I guess.
Yes, I am.
Store ID 500.
So
okay, so a different store ID.
Yeah, so the store ID for this price label is going to be 500.
Whoa.
You see it switch?
Yeah, I think it's, it's a bit blurry, but yeah, I can see it says 250. I think it does. Come on, cameras.
It is 250. So hopefully the audience.
You should have shipped me. You should have shipped me the label first,
Yeah, that's a good point. They should have shipped me label. So you could imagine. I'll go ahead and share my screen again. So you can imagine like you have thousands of labels in your storefront, and how do you direct an update to a specific label, right, in a specific store? And so that is the power of event.
See your finger now.
Oh, sorry. Let me.
That's all right. So like So if you had a store full of like electronic pricing stickers or labels, you could just push it using AI. There you go. You're back. And is it a topic again? Is that what's happening? It's publishing a message.
Yeah. So let me go over the architecture of the exact of the project, and also go over the topic taxonomy as well. So how does this all work? So we have the large language model, in this case Claude. We used MCP, which stands for Model Context Protocol, which essentially is a standardized way for large language model to attach itself to external tools. So in this case, the tool over here takes price updates and pushes it onto Solace. Okay, so we had to implement an MCP server, and the MCP server, what it does, it takes the prompt and then constructs a topic out of the various attributes within the prompt, puts it on Solace over REST, and then if the data is being pushed to a price label, it's going to push it over MQTT. And if it's pushing it out to the e-commerce storefront, it pushes it out over SMF. So the multi-protocol support of Solace was tremendously valuable here. So this sub-project consists of various components or various directories. You have the MCP server, you have the digital price label, you have the website, and then going to the topic taxonomy, right? So you could see over here that, you know, it's a retail, price update, store ID, and product name. And so you were able to, you know, if you have thousands of labels across a store, each of those would have its own product name, and you could say that I want to update, you know, for a specific store ID. In the case of the example that I posted with the digital label, the store ID was 500. Imagine you have thousands of those, and you have a product name, which essentially is a label for the specific price tag. So you could play around with these attributes or update or input the prompt for, and then the Solace MCP server will essentially construct the relevant topic based out of what you put in the prompt. So I put store ID.
So it's the MCP server that has that information, right, to how to build the top. Okay.
Exactly. Well, the MCP server, essentially when you create an MCP server, what you do is you specify a schema for the prompt. Yeah. And then what the using the MCP APIs, and then what the large language model will do, it will call the MCP server, and using the APIs within the MCP server, it will take out the various attributes from the prompt and then put it into a topic and the associated payload as well.
All right. That's we got to keep going here, TK. That's amazing. This is available on GitHub, right? Let me just flash up the link here. This is available publicly, so if anybody wants to go and try this out themselves, the link is just down there. Thank you for coming on and presenting. Oh, I did have there was one kind of funny comment here from our friend Running Roach. He needs a case of event mesh candy for his developers. We'll see about. We're going to ship that out to Hong Kong. We'll sort that out. Definitely awesome. All right. So thanks, TK, and we'll see you next time. All right. Next on the list. All right. Have a good one, man. Next on the list is our friend Himanshu. So let's bring him on. Where is he? Right there at the stage. There we go. Hey, Himanshu. How's it going?
Hey, Aaron. Good. How are you?
I'm all right. I'm hoping that this all works out today in terms of timing. I don't want to run behind and keep people waiting. So, so do you want to do a little introduction to your demo before we play this is going to be a pre-recorded video. So yeah, do you want to set it up first?
Sure. Yeah. My name is Himanshu. I'm a solutions architect at Solace based out of New York. And my team consisted of my colleagues, Mar Rodriguez and Matt Stobo. So, you know, we took inspiration by looking at TK's demo, and we said, no, we need to do something better. We need to have something more engaging. And you know, what was up with that otter spinning around on what looked like a spaceship, right? So we built something more realistic. And no, I'm just kidding. So for our demo, we built a trading signal dashboard where we're using AI, an LLM model, to do the sentiment analysis of incoming tweets and kind of show everything in real time along with market data that is being generated. And the kicker here is that the whole thing is built by AI. So I've been playing around with different vibe coding tools, right? So Lovable, Replit. So I spent a good amount of time building this through Replit, but then things didn't really work out. So I switched over to Cursor, which I would definitely recommend. And yeah, so the whole thing is built by AI, and it's really good because I've never had the sort of the front end skills that I've always wanted. So this is a full front end kind of visual tool. Yeah, let's kick the demo.
Awesome. All right, here we go, everybody. Let's see Himanshu's demo in action.
So for our demo, we built this trading dashboard, which basically shows you AI generated signals based on tweet content for specific stocks. So in our for our application, what we've done is we've designed the architecture using Event Portal. As you can see over here, we have 3 different major applications. Really the main dashboard, which we were just looking at, and the 2 different feeds in the background. So you'll have the backend market data publisher feed and a Twitter publisher feed, self-explanatory of what they do, and they have their corresponding events. So market data publisher will publish events on very well-defined market data topic. So in this case, that'd be market slash dash data slash asset class, country, exchange, and symbol, and has this on JSON schema. We similarly have an event for tweets that are published, and sorry, you can see over here then that they are set to Twitter dash feed slash symbol. These tweets are subscribed to by the Solace AI micro integration, and basically what it does is listens to the tweets and using a prompt outputs a signal, whether it's buy, sell, or hold. And the signal is published to signal slash symbol, and it has a specific schema as well, JSON schema. And dashboard subscribes to the signal data, which contains the actual signal, but then also the tweet, and then the market data. All right. So if we go back, you see that on the left-hand side we have the panels for the user to enter front end and back end Solace connection details, and that's because we do have an event mesh model here. We have two different services, Himanshu-Demo, which is used for backend services, and Himanshu-Frontend, which is used for our front-end dashboard. And they're meshed together using Mesh Manager. It was very simple and easy to do. And if we go back, all right, so let's use WebSockets to connect to front end. And we'll use TCP connection for our back end. All right, and once we do that, we have the option to select stocks explicitly. So we can add Apple, and we can well, let's add something else. We can add IBM, and we can add Tesla. Right, so we can explicitly add stocks, and if we look at the front end service, you'll see that it has a connection from username dashboard. This is our dashboard using JavaScript API. And if you look at the subscriptions here, it's subscribing to the signal data from the AI connector or micro integration, which also contains the tweets. Then it has these explicit topic subscriptions, which are these stocks that are just there. They're not selected by the user, but they're there, and we need data for them. And then we added IBM and Tesla, right? So we can see that those are over here. And if the user wanted to not have to subscribe directly using specific stocks, they can use Solace's wildcard technology. So here we can subscribe either by exchange. So let's try Singapore exchange, and by country as well. So we'll subscribe to Japan, right? So we see over here that we've added stocks that belong to Singapore exchange, as well as stocks that belong to Tokyo Stock Exchange. All right, so we go back to subscription, and you'll see that now we're using wildcards to subscribe to all of those stocks instead of explicitly specifying which stocks I wanted. And if I were to remove one of the stocks, for example, Tesla, go back, you'll see that that topic gets unsubscribed. So now what we'll do is start our backend services. So we'll have market data publisher and Twitter publisher. And while that's happening, what we can also do is use Aaron's tool to subscribe to data on one of the brokers and see what kind of data is flowing from our backend services. So let's do that. And immediately you see that we're getting data for market data, we're getting some signal data, and now there comes the Twitter data, right? So that's pretty cool. You can see all the securities. These are the securities that our dashboard has subscribed to. So we're publishing Twitter data just for the security that we're subscribed to on the dashboard, but we do have a more broad market data feed that's just publishing data for a bunch of different exchanges and countries. So if we look at, let's sort by number of messages, you'll see that we have a lot more market data than we do have Twitter data or signal data, right? So we can close that, and by now you'll see that we have market data being displayed, as well as the tweets and different signals. We can also show eliding capabilities. We're publishing data with eliding enabled already, so let's speed up and disable eliding, and you'll see we'll have a lot more market data flowing. All right, so you see a lot more updates happening, but because this is a visual dashboard, you and I can only process so many updates every second. Really, you don't need so many updates happening on the market data side. So what we can do is use eliding to not have to see so many updates. So the client profile that this user that we use to sign into the backend Solace connection does have eliding enabled, and it's set to one update every 500 milliseconds. So we'll enable that, and you'll see the updates happening slowly now. All right, so much more slowly than before. And that's it. That's our demo. Thanks for watching. Take care.
Nice one. Hey, all right. Thanks, Himanshu.
All right.
That was. I have a question. Why was
Yep.
there two different? Why was your browser connected to two different brokers? Like, why did you have a front end and a back end connection?
Yeah. So one of the requirements
connections to the same-
for the
same app.
one of the requirements for the Demothon was to show the capabilities of event mesh, so having multiple nodes. That's why I added the capability to have a front end broker setup that's using just front end technologies, and then separate connection for backend. Typically, you might want to size your brokers different, right? So backend, you're streaming a lot of market data in there, so you might have a beefier broker for backend, and you might have a small front end broker. So how do you stream the data together from one broker to another through an event mesh? I wanted to show that capability. You can very well just use the same broker credentials to just use one broker.
Yeah. So you were trying to model reality essentially, right? To make it a bit more real. Obviously, you could have just done it with a single broker. So that's pretty cool.
Yep.
Eliding is not something a lot of our modern use cases kind of see. They're all about guaranteed messaging. So yeah, eliding for direct messaging, for kind of reducing the crazy velocity of some of these market data feeds. If you're just looking at a dashboard, you don't need to see 10,000 messages a second on your screen going by there,
Okay.
right? So that's a pretty cool feature that definitely comes in handy. All right. Yeah. Well, thank you very much. Thanks for joining and showing us your thing. I'm going to bring on, who's next? What do we have here? Oh, it's Alessandro, and we're going to do this live. See you, Himanshu. Have a good one. I'm going to add Alessandro to the stage. There we go. See you, Himanshu. Bye-bye.
Go.
All right.
Hello,
here we go.
Aaron.
Hello.
How are you doing?
Hello. Alessandro, welcome to the stream. You are demo number 3, and you're live. So I hope this works well. Let's go ahead and share is your share screen shared yet? Or do you want to do it like?
No, not yet. I will do it in a second. Yeah, I'll just
do an intro. Yeah, go ahead. Go for it.
Yeah. So representing Italy, SC for Europe South. So today I'm going to talk about geolocation events, and it's we're going to talk about a framework that I built. And the objective was actually to make a demo reusable in terms of how do you visualize geolocation events, and how do you manipulate them, how do you actually interact with them. And actually we've built this together with my team, so Aditi and Srijit. Aditi is in the call, so I'm saying hi to her. The idea was, so let me share my screen now. Share screen. Coming, yes.
Do I see it? There, yep.
Yeah, it's coming. It's coming.
Nope, wrong one. Yeah, got it. This one. Click.
You seeing? Okay, perfect. I was not seeing. Okay, so good.
So no, hold on. I have to remove mine, I think. There we go. Now we can
there you go. Okay.
Beautiful.
Good. So the framework is called GeoBuilder, and I guess you know this one because it's a basically, I started with so the genesis of this demo is I started from a demo you built for Singapore and some other builds from other locations. And the idea was how do I rebuild this demo for a different location, for example, for Italy, for a region that I know. So I thought, okay, instead of retaking the code and rebuild it from scratch, let's build something reusable so that anyone else that wants to build it can, make very low effort and pick it up and just run it in any location in the world. So
Awesome.
What is it actually? So GeoBuilder is it's a framework that allows to simulate basically geolocation events, simulate and manage. So either you have geolocation events from a source, or either you want to generate them for a demo. So that can do. And it's about things that move around the world, in any location in the world. So it can be people, it can be objects, it can be vehicles. And and all of that is based on, of course, an event-driven architecture, right? So that's where we base the architecture. And in the demo, we'll see also that there's a client, actually, this is the one that you built with, and I tried to a little bit make it reusable. There's a front end based on a browser with HTML and JavaScript that allows you to render this thing on a screen. So you have events coming in, you have things moving, and you can render them on a map, so on Google Maps. And so you can actually use this to then publish these events that might be generated or might be real from sources, for example, from sensors, and liberate these events and send them to an event broker, and in this case, a Solace event broker, and we can visualize them on a Google Maps browser, as we said. And again, it's going through a broker, right? So we can democratize these things because any other application, not just the Google Maps, can connect to that and leverage these events for specific operations. We're going to talk about it. And then there's the last part, which is probably the most interesting. The applications can react to these events because, well, as we will see, there's capabilities in this framework where you can detect if an object comes into a zone. And that can be very useful, right? Certain situations, and we're going to talk about it. So in this case, I didn't have events. So what I did is I said, okay, how can I actually generate these events? So I thought about building something that is very easy for anyone to pick up. So I actually used the Google Maps editor. So as you can see, this is Rome, so it's Italy, so it's a location that I know. And we're going to look at the airport. So what I did is actually went into my Google Maps editor and built a set of paths. So this is actually the path that objects will follow, right? So it's a simulation. I spent quite some time to do this. But as you can see, there's two types of objects here. There's paths, so it's vectors, basically, and there's some zones. So these are polygons, the black ones. So the zones identify a zone where I want to have events detecting people coming in and out of the zones, and the path are actually for the people to walk in or to objects to move on, right? So once you design all of this, you export this to a file, and the idea is that then I want to run my generator. As my generator, I built a Docker, so a Docker container that has everything, right? To make everything simple, deployment very simple. So all you do to the Docker container, you give it the files that you exported from the map, you run this Docker container. This Docker container will do two things. It will generate events of things moving along those paths that you saw before, and it will also generate the fence detection events. So if an object goes to one of those zones, it will generate an event, right? And we'll see that can be very, very useful. So it's as simple as that. So we're actually going to do this. So let's just jump to our map. So this is the runtime map. So as you can see the event, there's nothing here. We'll just refresh the map to make sure that everything's connected. And then we're going to go to our command line. There you go. I think you can see it. Yeah. So what we're going to do is we're going to launch our Docker, and what we're going to do is, in the Docker here, you can specify how many objects you want, like how many people do you want there, how many planes do you want, how many vehicles. So we're going to start with 100 people, like a small number, just to make sure that the demo is visible and we can understand. So let's go for it. So let's put my password. Type it right. No, I didn't. There you go. So there you go.
Whoop.
So
there's
people. Switch back.
Yep.
There you go. There's people moving. So this is 100 people, and then we have like 20 planes. You can see the planes taxiing from the runway to the gates. And it's interesting. If we zoom in, we can see actually the detail of the people walking here. So what I can do is I can activate the fences. For example, I built the fences for shops, for example. So there you go. So when I activate them, what happens is I can see triggering these events that say, oh, these people went into this shop. These people went into this restaurant, for example. Right, and I have the detail of who went there. So with the ID, and the idea is here, for this use case for the airport, we're tracking people by using, for example, a Wi-Fi beacon or Bluetooth beacon, right? So we have got an ID, and we can use, for example, an app they're using to notify them and send them, for example, a coupon. So that was what I was talking before, is that you could use this as a marketing application, for example. So I want to, for example, send a coupon for people who are directing in a certain direction, went to a restaurant, and then they went to a luxury shop. So maybe they want to buy this, and I want to send them a coupon, for example. And given that we're going to an event-driven architecture, you don't have to use this map. Your marketing application can connect to the broker, react to these events, and do whatever it needs to do. So that's the principle. And as you can see, you can track the single, you can interact with a single object. So you can see, for example, all the details. We picked a person, for example, and we can see the Wi-Fi ID and the direction we're going. And for example, if we look at a plane, for example, if we click, let's see if we find one, this one. So it says also the heading and some directions and some vector information on how it's moving and things like that, and the interesting information. So an interesting thing is that you can see here on the bottom, you can see actually the events that are flowing right to the broker. So it's displaying the events, and as you can see here, we're actually using dynamic topics. So the browser is acting as an application which is subscribing to all the events. And again, what you could do is you could say, oh, I want to just see, for example, people. So we have filtering, right? So as you can see, it says change the subscription. We're only seeing people here. So this is interesting. If you have thousands and thousands of objects and you can't visualize them all because it will slow down your browser, you can just filter what you want to see. And this is another capability, of course, that we have out of our event mesh. So we're going to put it all again. So just to show you that this is interesting and scalable, what we're going to do is we're going to stop this. So again, it's another feature where you can very easily control how you want to run the generator. So we're going to stop the Docker container. So you can see it's actually draining, all the remaining objects. It's going to stop in a second. And what we're going to do is we're going to increase the number of objects just to see how this thing scales and how it works fine. And so we're going to refresh our screen. So we refresh our connections. I'm still there?
Yep.
Yeah, okay.
I'm just saying all the people are gone now, so.
Okay. So yeah, they're gone and they went to bed. And we're going to do from 100, we're going to put 600. Like just try and see, the real confusion that's going to come. Yeah, there you go. So you can see the number increasing right here, and the speed of events is increasing at a pace, and like we've got 600 people right here. And it's nice. If you zoom in, you can see the details. People actually moving through the security zones. So for example, I can say activate the security fences. For example, the security fences. So this is, it's very fast. You can see all the events of people coming in the security zones, right? So I can use this to count, for example, people in the security and say, for example, too many people are lining up on this security zone. Maybe I'll move some other people there. So I'm sending a security person. So a person can walk in the airport with his mobile phone, subscribe to the events, and say, there's too many people bunching up here. So we'll just move the people here, open up the new lane and things like that. So it's really helping dynamic situations like this in an airport. And again, we're showing an airport here, but the framework is generic, right? You could use it for anything. Like you want to do a retail demo, you can do it. You want to do a warehouse demo, you can, right? And you can even change the icons. Like, if you want to, for example, do a retail demo, you could put some carts, right? You could see the carts and you could put sensors on the carts and see how the carts are moving, and there you go. You could have an intelligent retail tracking of people, how they move into the supermarket or how they move in the shopping mall or things like that. Again, one of the last things, again, we can't not talk about AI, of course, right? And again, AI is just another application, right? And with Solace, we've got, of course, our Solace agent mesh, and our capability is to build RAG. So what we could do actually is we could have a RAG set up with an agent that consumes these events. And we could have a chatbot, right? We could interact with this information without using a map, and just basically saying, tell me how many people are actually going through security in Terminal 1 right now. Or tell me, if people went to security Terminal 1 and then they left the airport, right? Or I want to know, for example, what's the average number of people that are going first to a coffee shop and then they're going to a restaurant, right? And not in the other order, for example. These are all use cases that you can actually fit down. And again, this is available. So what you've seen before, this is this is the link. So you could go out there and try it yourself. The code is there. You can build your Docker, and it's all available.
Awesome. And so this was a real use case for a real customer, right? For the Rome airport.
It was. So you've seen this. This is Rome Airport actually. So and we went out and showed this, and I actually used this to speed up the building of the demo because I had to do it in just a few weeks. So I thought about how to make it very, very simple. And you remember we talked about it, right? When I had to go for this. And there you go. Now it's a framework. Anybody can use it. So it's available.
That's awesome. So is this like tracking of like phones, MAC addresses, via Wi-Fi beacons? How accurate is it? I mean, is this real? I mean, that exists right now?
It's real. So actually the Rome Airport is actually doing this, although they don't have an event-driven architecture. They're doing it like in batch. I don't know exactly how they're doing, but they're using the Wi-Fi beacons. It's not very precise because Wi-Fi, of course, people connect to the Wi-Fi in the airport to get free Wi-Fi. So it's like a distance of between 15 and 30 meters, not very precise, right? And even though with the dimension of an airport is fine, but they're thinking about going to Bluetooth beacons. Bluetooth is much better because our phones are always live, right? And the Bluetooth connections, everybody has it on because you have your earphones, you have the watch or things like that, and these ones always ping. And there, the precision is between 10 and 15 meters. So it's much more precise, especially for vehicles and things like that. And again, the information, the things that come for you don't see planes anymore, but actually the planes, it comes from control tower. So as you can see, you have multiple sources, right? Publishing information to your broker, and you can visualize them in one map and then use them, for all the use cases I mentioned.
Very cool. Very cool. Yeah, perfect. We got a Mark back there. I love it. This is really cool. It was pretty cool. Yeah, cool. I'm glad the bus demo continues to live on in new and cool ways too. That's really awesome.
Exactly. So, forever. Anyway, it will live forever now.
The link is down there, everybody. So if you want to try this out yourself, it's just it's a Docker container. It's just easy to start up and just start publishing data, and you can build your own version of maybe New York Airport or somewhere else, right?
Yeah. And I did say that my eye candy was actually this picture that I generated with ChatGPT. So I asked, can you generate what is the GeoBuilder? And I described what it is, and that was the picture. It came out.
Cool picture, actually. Yeah. Awesome. Okay, perfect. Thanks, Alessandro. Thank you for coming and presenting here. And I know you got to run out and go pick up your kids from school, right? So thanks for doing this. All right. Okay, we'll see you next time. All right. Toodaloo.
Bye.
Bye. Let's stop that. This. All right. And so now, who's next? Sanjeev, your team presentation. Hello.
Hi.
Hello,
hey,
Sanjeev.
Aaron.
Hello.
Yeah. Thank you for having me here.
Thank you
hello, everyone.
Thank you for coming and presenting.
Sure.
Apparently, Ben said he was going to be on top of a mountain somewhere hiking, so he couldn't be here today to do the demo live. But,
yeah. I would have loved him to be here, but. But hello everyone. Thanks for joining. My name is Sanjeev Nagpal. I'm based out of New York. So before we start, as Aaron already mentioned, I just want to take a moment to acknowledge my colleagues, Ben Gatstein and Hank Spencer, who played a big role in building this demo. Although they couldn't join us today, their contributions were instrumental to this demo. So today I'll be walking you through a recorded demo of a retail use cases that was built specifically with Europe's largest retailer, Schwarz, in mind. The title of the demo is The Future of Retail Integration with Solace in Every Store. This demo illustrates how Solace's event brokers can be deployed in a matter of minutes in retail stores and connected with Solace Event Mesh with not much tech know-how needed. Solace Event Mesh, it can enable real-time integration across retail systems, from inventory and store operations to digital channels, allowing large retailers like Schwarz to, on one hand, liberate the master data, which has been sitting or hosted at their headquarters or central location. For example, inventory, products, pricing updates, and take that data and distribute to retail locations so they can react on changes in real time, like accurate product information, pricing and promotions, inventory and stock management, customer and loyalty programs, etc. kind of use cases. And now, on the other hand, it also allows them to liberate data from point of sales transactions in the retail stores, sales order data, and then streaming and filtering it, democratizing it to be made available for business applications like sales analysis, business intelligence, inventory management, pricing strategies, promotions, strategic decision-making kind of use cases. So that's the whole crux, this demo addresses. So with that, Aaron, without further ado, please, if you could.
Let's go ahead and play. I don't want to say, like, people might have noticed a couple keywords that keep appearing throughout our presentations here today, and that is liberate, getting your data out of your data silos and out of your systems of record, stream, which is to get them onto the event mesh, filter, which is to, using wildcards, topic subscriptions, and hierarchical topics. That's all it does. React, basically event-driven coding. So basically, as these events occur in your mesh, you can react to them. And then democratize, which is to make that data available to lots of different systems or people or whoever wants to consume that, right? So you'll hear this term a couple times more, I think, before the end of today. So awesome. Thanks, Sanjeev. Let's play the video and stick around for a minute. All right, here we go.
Our team is the discounters.
Discounters. So the goal of the demo is to have a very easy to set up, repeatable, and complete demo of the Solace platform for Solace in every retail store. You can apply any form of use case on that platform, which we'll show today. What we brought with you is the typical use case for retail. It's master data distribution to the store with product update events, as you can see in the EP model, and price events, which will be liberated by a demo publisher. And then we have 2 store brokers, which will actually consume the data. So let us have a look on the overall architecture, which we're going to deploy now live to make this very engaging. I was asked a lot about it in the team about, hey, could we have a demo to showcase Solace in every retail store very easily, and especially show that the broker is easily being deployed, like in a store infrastructure, but also is being easily configured, right? So what we will do now, we will set up the whole demo architecture you can see here. It is a demo publisher, which is liberating data from the EP model, which we just showed, master data events for products and price updates, to a hub broker. This hub broker will route the data to 2 store brokers, which will be deployed on my local machine, store 101, store 102, using VPN bridges for a bidirectional integration. And then I have a local consumer running, connecting to store 1 and to store 2 to consume the data. Everything will create traces for an end-to-end transparency of the whole setup. And then we will start up sales order feeds locally in the store to react on all those events in general in a AI-based 360 retail dashboard. So a good demo always is live. So we will deploy the whole thing now live with a script. We have 2 scripts, so you guys in the field can easily use it, a start script and a stop script. Easy. Start script, fire it up now. You see on the right-hand side my local machine, no containers up and running, so it's empty. It will now compile the demo publisher and the consumers. It will deploy the actual store brokers. So all the containers are now deployed. There you go. And now Terraform is waiting until the 2 local store brokers becoming ready to make the whole configuration. So all the assets we need for the demo, distributed tracing, the hotel collector, VPN bridges, is all happening now via Terraform to show also a customer how easy it's to automate all these things. So this was the hub broker. This is store broker 1. This is now store broker 2. And the store mesh is running. It's up in there. So we now switch the screen, have a short look to the cloud broker, that you can also see that all those assets were actually created. So if we go to bridges, you now see 2 store bridges, store 1, store 2, which are connected. And the first thing we have a look is transparency. So we are liberating events. We stream and filter those events. We react on those events, and they are democratized by the event portal. But the question is always in retail, how do I know where's my event? What happened to the event? And you see it here. This is an end-to-end trace from the publisher on the first hub broker to the store broker, where it's routed and filtered. So only the events for store one-on-one will be filtered to broker one-on-one, up to the actual consumer confirming that this event has been consumed. If you have more time, you can even showcase like how this would look like, if a connection would be down or the queue would be full. So you can, actually show some how it eases up their event flow. Now to show the open APIs and the interconnectability, we also start up Solace feeds with the point of sale feeds. It's connected to the local store broker. So all the feeds which are generated here are generated on the local broker, and we're just simulating store data, store orders, right? So retail orders in the store being generated. And just to visualize the whole thing, how does a smart topic look like? And yeah, how can I drill in this thing? We use the Sunburst Topic Explorer to look live into the feed we are currently creating and walk with the retailer through the different hierarchies, the product types we're creating, and the sales orders. And now, if we look back to our EP model, which is used for this whole demo, now we go back to the part where we react on those events. And we react on those events with a micro integration, AI, and a nice dashboard. Over to Hank.
Thanks, Ben. So as you were saying, right, not only are you able to use the event mesh to power your store operations, but we also want to show how easy it is to stream and filter that data to additional applications to be able to react. So here we have just a simple retail dashboard powered off those same point of sale data that's powering your transactions, master data management that's being pushed down to your stores to generate metrics, be able to react to in-store orders changing in real time. One of the things we also added in is not only a complete list of all the messages, those point of sale messages or transaction data that's being published, but showed how the different verbs and the different topics can be used to generate components for customer initiated orders, online orders, canceled orders, things like that, to help them visualize and understand kind of the different topic hierarchy and the power that can come with that. I'm going to hand the mic back to Ben as I type in a question, but we also have using the Solace micro integration to build out a simple kind of RAG-based chat interface on the dashboard as well. So if I do that, come down here, a summary of, whoops. Where's your Y on this quarter?
It's on the C.
It's on the C. Or 101.
Yeah, all good.
So European keyboards throw me on.
So it's the European keyboard. So it was just like, show me a summary of price updates for store one-on-one. And there you go. It shows like a summary of the data which it received from store one-on-one. And last piece, how can I get rid of all this stuff which I have deployed locally? Just execute a stop shell script and then everything is gone, right? And it's repeatable. All right, that's all.
There we go.
All right.
Hey, all right. That was a pretty good demo. Thank you for coming to present it and walking us through the stuff we were going to see. Discounters. I had to edit that from our actual kickoff event that was in London back in May. So that was a Teams recording, and the video feed for the camera on set was quite small, so that's why it was kind of pixelated there. But I think we got the demo across, right? So
Okay.
that was it was live from London there. So awesome. Thank you, Sanjeev.
All right. Thank you.
And
Aaron.
we gotta move on to our
Okay.
last demo here. So I'll see you later. So today's last demo is actually going to be an interactive one. So I hope there's a few people out there that are going to help out with this because it's going to be good. So to present, I actually have two guests to help out with this. Rainer and Emily, let's bring you on the stage. Hello both.
Hi, everybody.
Hi, good morning, good afternoon. So,
Good morning, good afternoon, good evening, depending on where you are watching. So why don't you guys go ahead and introduce your demo. Tell us what we're gonna see here.
Okay, so for our demo, as Aaron mentioned, we wanted something that was interactive. And the easiest way to do that in this forum is to utilize the mobile phones. So I'd like you to pretend that you are Amazon warehouse workers.
Okay.
Yeah.
Take your pick, could be UPS, FedEx. But the premise of this is that we'll be utilizing the gyroscopes and the accelerometers on your phone to track movement.
Aaron, are we sharing my screen?
Nope, not yet. I will share it right now. Let me just
Okay.
remove mine.
Yeah, that would help.
That's a
Okay.
visual cue.
I thought we
Thanks.
were just doing an introduction. Sorry about that. There we
Yeah.
go.
No,
Now,
it's okay.
you're there.
Sorry, no, you're,
Yeah.
yeah. So this demo was so Reiner, myself, and then John Adigbile, who unfortunately wasn't able to join. We're all part of the team that created this demo. So as I mentioned, the starting premise was something that was interactive.
Mm-hmm.
But now, in a moment, we will ask you guys to take out your mobile phone. So hopefully there are still folks around. And utilize the sensors on your mobile phones to track movement. Now, Amazon, being the king of efficiency, wants to track and incent worker productivity. So what we did was utilize the AI designer in Solace Event Portal to model an application to do just that. And as you can see here, like I think, I don't know if you can see my cursor, but over on like the top left section, it's going to be capturing your number of lifts. You could also capture steps logged and utilize all of that to capture the productivity, display it on a productivity dashboard that Reiner will show you later in the demo. But we've been talking about streaming events, filtering them, democratizing them. So once all of these motion events are being streamed across the event mesh, it's simple to filter it so that it's delivered, that the productivity applications receive just the data that it needs. And we've democratized it by making all these events available through an event catalog so that, other business units can also tap into it. For example, there's a pretty fine line between worker productivity and worker safety. So perhaps Amazon wants to make sure that the workers are, being efficient. However, the worker safety team is focused on ensuring that everybody stays safe and healthy. Mm-hmm. And we want to prevent liability, workers' comp claims, things like that. So we could easily take this data and feed it and have the event mesh tap into an AI agent that would measure posture detection and ensure that the workers are using proper form, that we're preventing any injuries from happening. If we had additional sensors, we could also capture body temperature or breath and lung health, so that, like over on the, I think is at the bottom left, things like fatigue or detection, or today in New York City we're about to hit over 100 degrees, so prevent heat stroke. And then create another, and then the safety dashboard could be displaying these, could send alerts, could proactively make sure that workers are taking a rest, drinking water, whatever it is, so that they can stay safe and healthy.
Cool.
Yep. So, of course, we haven't built this out completely yet. But just to show the bits and pieces which would be involved in a setup like this, what we did was we coupled at least the three basic ingredients. So there's motion capture application running on your mobile phone. We'll start that in a second, which will just publish sensor data. It's acceleration data, actually, in this case, to the event mesh, actually a single broker running here locally. Usually, at least in the notes here, like activity classification, posture detection service, you would have some sort of streaming analytics job running, doing, I don't know, aggregations, time window-based analytics, and maybe hooked up to a machine learning model to predict, for example, unsafe posture. So to show how all this can be interconnected, we will start with the most important part, and that's actually the sensor thing. So we're going to do two things here. One is we ask you to log into this website. I hope the QR code is working. I tried it earlier and it did work.
Oh, let's hope so.
And if you log into it, it would, and I'm trying not to scroll this outside. It will bring you to a little mobile app web page that will probably ask you for permission.
Yeah,
Yep,
like this.
that's it. Very fine. Put in your name or some sort of alias in there. Short names preferred. I think we can handle spaces these days, so it should be okay. Aha. You're supposed to do a bit of calibration then. And eventually, when you do some shaking and moving, that's actually, you have to start the rep counting thing here. Actually, maybe I should start it as well.
Hold phone still at each position, click the button. Oh, okay.
Okay.
Down.
Yeah. Don't tell people how to do something. Do it yourself. So the idea really is you calibrate for an upper part. Lower, you shake the mobile phone wildly. And what the little application is doing that's running here locally and which was actually written by John, it just collects acceleration data. And we are piping that, well, through a broker. And doing a bit of analytics for this here. And yep, the stuff is showing nicely on our local dashboard here. So for visualization, again, we use Aaron's famous Sunburst Explorer.
Sunburst,
so,
yes.
Yeah. So just as an illustration, what's going on here is what you can see here is 3 parts. The demo part here in green, this is the sensor data that is coming directly from your mobile phones. It goes through a gateway to a little Node.js JavaScript application, which just pushes it to the broker. So you can actually dial into this. You can see your names here. And Emily, for example, has been doing 16 repetitions now.
Wow.
And you can actually drill down and you can see the acceleration sensor data here. And it's continually being refreshed. So that's sort of the part, if you remember that diagram we had earlier, where the motion data comes in. For classification and a bit of analytics, you want to do something else. And that's why we hooked some streaming analytics processes up to the sensor stream. And this is all done in the broker. So you can switch off some of the parts. The rest will still keep on working. So this is the stats part. And what this is doing is, I used a little streaming application, actually 2, to do 7-second and 15-second aggregations over your motion vectors, or actually the acceleration vectors. So it's just simple calculations. And this is done from the data published to the broker. And the nice thing is you can actually see, okay, Jamimi got a couple of ones here. So this is your 15-second sum up. So you got something like a score of 2,484.
Not bad, Jamie.
Yeah. Under the covers, like I said, 15 seconds, 7 seconds. You could use any streaming framework like Spark Structured Streaming here. I used Flink for the simple reason that I'm familiar with it. So you got the streaming job here, and the metrics job is the one that does the calculations. So you get the metrics from a broker, and you do the aggregation over 7 and 15 seconds, and just publish it back to the broker. So anybody who's interested in the data can tap into this. Talk about democratization. That's what we're doing. And the third part of the demo, it's the leaderboard, is actually simply tapping into what stats is generating. And like I said, just coupled via broker. So what I'm doing is I'm just doing high scores over the 7-second averages, and it looks like the highest number is Sanjeev with 2036. I don't know what he did with his mobile phone, but he got by far the highest number. I hope you didn't throw this thing. It's going to break if you do that.
Awesome.
So it's straightforward. Sensor data, just publish via a little web app, push it to the broker. You could actually in real life have motion sensors in your equipment, maybe use MQTT for something like this. Then hook up your standard off-the-shelf statistics, analytics framework, use that stuff, and then feed other systems. You could actually hook a machine learning model, for example, instead of a leaderboard here. So this is all not rocket science. What we actually want to demonstrate here, how easy it is to decouple and really loosely couple the different bits and pieces you need for your applications via the broker. It's democratization of data. And that's pretty much the end of our demo.
That's fantastic. So I really like the fact that, you have Flink there that's pulling the raw data off, doing its calculations, and then just republishing it back, and then making that available as another feed, right? So you can either listen to the raw or the averaged or the processed versions of it, and just pick and choose whatever you want out of the.
You can see we got something like 3,500 records here. And that's the stuff that your analytics frameworks will do for you. But it's easy coupling of your components.
Very cool. Very cool. That's great. Well done. Thank you for presenting that and coming on the stream and waiting around to the end. Thank you.
No problem.
Really appreciate you guys. Let's bring whoever's back still here. Oh, Sanjeev, you're still here. Tamimi, you want to pop in as well? We say hello. There's a few comments I didn't get to, so I just want to kind of just toss them up here. I missed it actually. Sissy said hello. Where is she? From Essen. Hello from Germany. Another German. Well done. Thank you for joining and watching. Hari, teammate from the Netherlands. Hello. Thanks very much for watching. A couple cool demos, like outstanding demos. That was a cool demo. Yep. Thanks a lot for watching, guys. And Sravan tuned in towards the end here. Hello from India. Had a question about Solace and AI. Well, my last office hours was all about the Solace Agent Mesh, SAM. And so if you go onto our YouTube channel, youtube.com/ I think it's just @solace.com. There it is, @solace.com. You can find last month's office hours where Ed Fonnecotter presented it. And it is available on GitHub. It's you can just go there, you can download it. I'm sure if you just search for Solace Agent Mesh or Solace AI, I'm sure you'll find all sorts of information there, Sravan. So thanks for the question. And that's I hope you enjoyed it. And one last one here. Good evening from Singapore. Hey, Sumit, how you doing? Thanks for tuning in. It's going to be late there for you. All right. Thanks, everybody. I think we're done. Thank you to everybody who presented. Thank you to all my colleagues for coming and showing off their Demothon creations. It was a really, I think, a pretty fun episode. So thank you for joining. Thank you, everybody out there, for watching. I will be back next month. I'm not sure what my topic is going to be, but I'm sure it's going to be something product related. These fun ones are great, but we have other things of the product that we have to show off. So thanks, guys. Good to see you. I'll see you next time. All right.
Sure. Thanks.
Thank you very much, Aaron.